Hey, we are carrying on with Chapter 8. As you can see from the video, I'm going to cover 8-2 and 8-3. As I mentioned earlier, this goes really quickly. There's not really a lot of new ideas here. I find that students pick this up pretty fast. I hope that works for you. If not, again, please come see me, ask questions, we'll go through more examples. So we have the products and powers of powers and quotients of powers. So let's kind of go through 8-2 real quick. And for this first idea here, the relationship between repeated multiplications of powers and products of powers can be themselves written as powers. Well, what does that mean? That means if I have a value where the base of the exponent is the same, and I'm multiplying two powers together, then I simply add the exponents to get the result. Let's look at what that means. If I have 2 squared times 2 to the third, well, what this says is that I just add those together. This would be 2 plus 3 is 5, 2 to the fifth. Well, let's see, 2 squared is 2 times 2. And 2 to the third is 2 times 2 times 2. And a power is repeated multiplication, and it's repeated 1, 2, 3, 4, 5 times equals 2 to the fifth. That's why this works. Okay, got it? Good, we're moving on. Power of a power property. Now this is a little different, and this is saying if I have a base b and I raise it to the m power, and then I raise that whole thing to the n power, then it's b to the m times n. Well, why is that? Again, I'll use 2's, so let's take the 2, we'll go 2 to the fourth power, and we'll square that. That'll be 2 to the second power. This tells us that that's going to be 2 to the 4 times 2 equals 2 to the 8th power. Well, what does this mean to us? Remember, we do what's in parentheses first. And so first we would take this 2 to the 4th, and 2 to the 4th is 2 times 2 times 2 times 2. And that whole thing squared means it's times itself. 2 times 2 times 2 times 2. That's what this says. So 2 to the fourth, that's 2 to the fourth, there's 4 2's, times 2 to the fourth, there's the 4 2's. That's what squaring that means. And how many do we have all together? 1, 2, 3, 4, 5, 6, 7, 8. It equals 2 to the 8th. That's why that one works. Okay? Remember, there's the power of a power and product of powers. They're different ideas, but in this case we're squaring, for the power of a power, we're squaring a power or raising a power to a power. In the other case, we're multiplying them together. What about the quotient of powers property? This tells us that if I have two powers with the same base, and I divide one by the other, then the power of the exponent in the numerator goes first, and I subtract from that the power of the exponent for the denominator. Okay, back to our 2 example. Let's go 2 to the 5th divided by 2 to the 3rd. And they would tell us that that's m, the numerator's power, minus the denominator's power. That's 2 to the 5 minus 3 is equal to 2 squared. Why does it work? Remember what 2 to the 5th represents. It represents 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Yeah, there's 5 of them. 2 to the 3rd is 2 times 2 times 2. Now the 2's cancel out here. We create 1's, correct? So that cancels, that's a 1. This cancels, that's a 1. This one cancels, that's a 1. That leaves us with 2 times 2 over 1, which is equal to 2 squared. That's why it works. Okay, we got it? Good. Let's go through some examples and see how well we got it. So our first example says simplify w to the 4th times k to the 9th times k to the 3rd times w squared times k. And we could ask yourself, wait, these don't have the same bases. How can I do that? Well, let's see what we can do to sort that out, because some of them have the same bases. So w to the 4th times k to the 9th times k cubed times w squared times k. I'm going to rearrange these using the commutative property of multiplication and put the bases together. I have w to the 4th times w squared. That's times k to the 9th times k to the 3rd times k. Well, w to the 4th power times w squared, I add them together. 2 plus 4 is 6. That gives me w to the 6th power. And for the k's, I have k to the 9th power plus 3. So that's 9 plus 3 is 12. And this is k, just k, so that's k to the 1st power. There's a 1 that's implied there. We don't write it, but in this case we have to add it in. So 9 plus 3 is 12, plus 1 more is 13. It's k to the 13th. Okay, that's it for example 2. Remember this implied 1 when we're working with them. For example 3, it says write 3 to the 8th power, all of that cubed as a single power. So 3 to the 8th in parentheses, that's cubed, that's 3 to the 8 times 3. And 3 times 8 is 24, so that's 3 to the 24th power. That's our answer. Example 4. Simplify. Ooh, this is getting more complicated. 2g times g to the 3rd raised to the 9th. Okay, so we got 2g times g to the 3rd raised to the 9th. First I've got to deal with what's in parentheses, and well, it's just going to be g cubed. Then I've got to deal with my power, that's raising that to the 9th. So I got 2g times 3 times 9 is 27, g to the 27th power. Now I have g times g to the 27th, so that's going to be my product of a power. So that's just 1 plus 27, so it's 2 times g to the 28th power. 27 plus 1 is 28. That's my answer. This isn't 2 g's, it's not, this is 2 times whatever g is, so it's a doubling of g, whatever that value might be, but it's not a squaring of g. So this is not g times g, right? It's just 2 g's. So that's it for this first set of examples. Let's move on. I want to go back here and look at, we just went through the product of powers property and the power of a power property, and we combined them and used both properties at the same time. Orders of operations still apply. We need to pay attention to it. Now we're going to look at some quotient of powers problems. This is an activity. It's on page 469. Simplify each expression. Remember, the quotient of a powers property says that if I have b to the m divided by b to the n, it's equal to b to the m minus n. So b to the m minus n. So this is equal to go down here with this. A. So a to the 7th over a to the 4th. A is equal to a to the 7 minus 4, and that equals a to the 3rd. For b, we have y to the 12th over y. This is equal to y to the 12th minus 1, because that's, remember, that's an implied 1 power. So that's equal to y to the 11th for b, m to the 14th divided by m to the 5th power is equal to m to the 14 minus 5, and that equals m to the 9th power. D, n to the 13th power divided by n to the 13th power is equal to n to the 13 minus 13, and that equals n to the 0th power. And we know that anything raised to a 0 power is equal to 1. Let's take a look here. The 0 power. In question 1D, which we just did, you should have seen that it equals 1. More generally considered the fraction by the quotient of powers property. If we have b to the m over b to the m, it becomes b to the m minus n, which is equal to b to the 0. So we know that any non-zero number divided by itself is 1. So this is the same number. It's going to be 1. B to the 0 is 1. It's another way of showing that y, b to the 0th power, or any exponent to the 0th power, equals 1. We can use this for scientific notation problems as well. Remember that scientific notation is some number, an integer from 1 to 9, including 1 and 9, in the ones place, and that's it. So I have some value in the ones place. I can have whatever I want to have after the decimal point, and that's raised to a power of 10. Well, we can take the area of China as square kilometers. The population is in people. What is the people per square kilometer? So if I want peeps per kilometer squared, that's the units, and so I've got my people here, and that's going to be having trouble with my writing here. Okay, here we go. That's going to be 1.313973713 times 10 to the, however, how many decimal points did I have to move this to get it from the end of the original one to where it is here? Well, I had to move 1, 2, 3, 4, 5, 6, 7, 8, 9. I had to move 9 positions, so that's 10 to the 9th power would move it back where it belongs. So this is in scientific notation for the number of people. For the area of China is in square kilometers, and that's 9.596,960, and again it's times 10 to some power. How far did I move it? 1, 2, 3, 4, 5, 6 places. Now where this is useful to us is the base 10 for these powers are the same base. They're raised to a power. So now I can use this quotient of a power to subtract 6 from 9, And then I can do my division of these two numbers to figure out what I'm going to get for my result. And so what I will get out of this is that's going to be 6 from 9 is 3. So that's going to be 1.313973713 times 10 to the third divided by 9.59690. And I've got a somewhat simpler problem. 10 to the third means 1, 2, 3. That's 1,000. So I've got 1,313 divided by my 9.596960. I'll do my division, and I get that since I've got to approximate for people, I can't have fractional people, about 137 people per kilometer squared. So that's where it's useful in working with large numbers. It gives us a way to reduce this down to a smaller, perhaps more workable number using scientific notation. This kind of technique was certainly far more in favor before graphing calculators, because you might ask yourself, why couldn't I have just put this original number in a calculator, punched the numbers and gotten it out? The answer is you could. And with them it certainly makes it easier, but it's nice to know some techniques to simplify it should you find yourself without your electronic advantage. Okay, I'm going to go through one more example for these two lessons. This last one says to simplify this expression. And much like what happened when we did it with when we used the powers with multiplication, now we have values with different bases and we have to sort through each one. We can do that because the fraction bar is a grouping symbol. So I got 40b to the 10th times c cubed over 8bc squared. I can work with each one of these exponents. Well, I could first work with my numbers. 8 goes into 40 5 times, so this is pretty easy. I got 5. b to the first over b to the 10th over b to the first becomes b to the 10 minus 1 times c to the third minus 2. So 5b to the 9th, just c, because it's c to the first. The 1 is implied, I don't need to write it. Here's our solution to the simplification. b times 5 to the 9th, c to the third. Now, you might ask yourself the question, and we're going to get into this in a little bit, is what if the denominator is larger, the exponent of the denominator is larger than the exponent in the numerator? And the answer, as we're going to find, is you just do the subtraction and you end up with a negative value for the exponent. And in our next lesson, we're going to talk about what that means.